Hello and welcome back to our series of surface modeling for this 3D scanned data. We are going to approach our last basic surface, which is this curved saddle kind of like surface right here. And to do that, we're going to need some generation curves. And we can do that by using the cross-section tool in a clever way. So let's first clear all the current cross-sections. We also have some old template curves here that we don't need. So pick those. So what I'm going to do now is to create a new kind of a cross-section of our scan data along this curve right here, the end of this surface here. So I click on New in my cross-section tool, which is located down here in the control panel, and I pick Radial, and I choose number of planes, which is set to 10, which is probably good, and I click that curve. What you see now is a even distribution of 10 planes, infinite planes along this edge right here. So let's go for that. Pick object, pick that one, and apply our just created radial group, like so. And the point here is to create generation curves for this surface here that goes normally towards this curve right here. And if I'm happy with that, I'm going to go again with the curve edit and fit curve and choose a couple of these just to see that. Let's turn on this one again so we don't step into the transition surfaces here. So let's work with this one right here, like so. And again, I need to pull these handles. It stops there. I'm going to bring it up slightly more. This one needs to come all the way over here. Now we can fine tune it, pulling it maybe up to there and up to there, something like that. And again, you can see that the fit curve tool works very well. We get an approximated NURBS curve within 300ths of a millimeter in that end right there. We are going to need another one. Let's use this one here also. I'm bringing it up to there, click the other handle and take it over here. No, let's not do that because we want the surface to be symmetrical. So what I could do in order to create an entire surface here is to actually mirror this curve that I just created. Let's do that. Pick curve, like so. Edit, duplicate, mirror across the XZ plane, go. And then we have another one. It should be identical in distance to our cross section. It looks very nice. So I have those two, and that's probably going to be enough. Now I'm going to need some kind of rail curve along the surface. I'm going to try using a bi-rail or even a mono rail to create this surface. So let's bring on some Z sections and see what that does. We clear these. We can also, let's keep those. So we'll bring on the Z with a 5 millimeter increment, take our scan data, apply it, and see if we get any luck. Your one there. I'm going to tighten this up to 1 millimeter. See if I get one that's really close. And that one looks good to me. So let's use that one and see where that takes us. So if we go with curve edit, fit curve, and then I pick this one right here, close to the end of our generation curve, like that. And as usual, I need to bring that one back to somewhere in that area. And that one will even snaps onto that. That's nice. See if it does that in the other end too. Yes, it does. All right. See if we get lucky with this one. Let's try just run a mono rail with one generation curve and one rail curve here. Clear our scan data, go to surfaces, swept surfaces, rail surface, one generation curve and just one rail curve. So we sweep that one along this one like that and see where that takes us. We do have a surface there, absolutely. Let's bring in analysis on, and why not use our newly created radial group analysis. That one was, oh, there we go. And see how close we get. And it looks extremely good, I must say. Very, very nice. You can see that we're really close to our scan data here. Let's not forget to make this symmetrical before we finish. But let's also measure the distance using the deviation map set to 0.1 millimeter. Getting cocky here. Except click the scan data and it's almost entirely green. We'll bring that up to 0.2. I think we should be okay. Absolutely. This corner right here is probably out in the transition surface that goes here. So we don't need to worry about that corner right there. Let's make this symmetrical. So I pick the surface, I kill the history, and using object edit, we make it symmetrical. There we go. And all of a sudden we have a deviation here, which is not very nice. Whatever happened there is not something I want. Okay, there was some kind of glitch there, so I paused the recording and ran this surface again with surfaces, rail surface, and I've killed the history on this surface, and now we make it positively symmetrical by using object edit symmetric modeling like so. And we can now see that it's still very close to our scan data. And the final thing I would like to do again is to extend the surface so that we can run our transition surfaces along this edge right here and along the edge right here. So I'm going to use extend merge on the surface and stretch it up slightly like that. And keep a close eye also on the cross sections here so that we don't deviate too much. Also, this end right here needs to be stretched a bit. And again, we keep a close eye on let's also measure that just to make sure. So evaluate deviation map 0.2, we pick the surface and we pick the scan data and see, okay, so there is an area here that is outside of our tolerances that probably needs to be addressed. We only ran one generation curve. If I would have added another one here, I could probably have controlled this area as well. But we can do that by working the CD points as well. So let's do that. We'll add another row of control vertices right here, and now we can work with this central area here. So I'm gonna pick those CDs, those two, and work them normally to the surface and see what that does. Oops, I need to set the sensitivity of the mouse here in order to move a bit slower. So I'm bringing those down ever so slightly. And there we are. These areas here, we don't need to worry about because we've already wandered out to the transition surface like so. And I think that's going to do the trick for us. Maybe this area here needs to be addressed as well. Let's take this CD right here, move it normally to the surface and bring it in slightly. And there we are. Okay, so now we have all our basic surfaces. It's time to start working on these transition surfaces as well in corners. I'll be back shortly.